Lesson 6.4, vectors and dot products. There's two ways to multiply vectors and scalars. It's a dot product or a cross product. For example, if we have a scalar times a vector, which is a cross product, we get a vector. For example, if we had 3 times 4, 2, vector 4, 2, we multiply the scalar 3 times the vector, we get 3 times 4 is 12. 3 times 2 is 6. So the answer is another vector. Now if we do a vector dot a vector, we get a scalar. And we're going to do that next when we define the dot product. So we have also have a vector cross a vector. That gives us a matrix. We're going to do that in chapter 8. And if you tried to cross a vector with a scalar, instead of a scalar cross a vector cross scalar, you can't do that. No. Yeah, that's just a no-no. All right, let's look at our dot product definition. So if U is a vector, and we'll say it's U1, U2, V is a vector, call it V1, V2, then when we dot U and V, we get U1 times V1 plus U2 times V2. And that is a scalar. All right, let's look at the properties of dot products. There's 5 of them. First one here, if U dot V is the same as V dot U. Second one, if we multiply vector by 0, we just get 0. Third one, U dot V plus W. Then it's just U times V plus U dot W. And the fourth one, V dot V is just the absolute value of V squared. And the fifth property, C, which is a constant times U dot V. You can multiply the constant times U and then dot it with V, or you can multiply the constant times V and dot it with U. All right, let's look at some examples. So we want to solve vector 3, 4 dotted with 2, 3. So that's just 3 times 2 is 6 plus 4 times a negative 3 is a negative 12. 6 minus 12 is a minus 6. Now, if we wanted to cross that, because we can, 3, 4, and cross product with a 2, negative 3, what we get is a determinant and a matrix. Well, it's a matrix solved by determinants, so you write it as 3, 4, then the 2 minus 3. Write it in matrix form. To solve that, you might remember it's 3 times a negative 3 minus 2 times 4. So it's a minus 9 minus 2 times 4 is minus 8. I'll get a negative 17. So that's the matrix solved by determinant. That's the difference between a dot product and a cross product. So we'll do more of this when we get to chapter 8. So the next example, I'm going to solve the vector 2, 2, dot it with 1, negative 1. So 2 times 1 is 2, plus 2 times the negative 1, negative 2. So that's equal to 0. And let's look at the next one. Solve vector 0, 4 dotted with 3, negative 2. 0 times 3 is 0. Plus 4 times dotted with a negative 2, or times negative 2. It's a negative 8. 0 and negative 8 is negative 8. All right, let's look at the next couple of examples. Here we have U is vector 3, 4. V is vector minus 2, 6. W is vector 1, negative 1. So we want to find U dot V and then times W. We could have put a parenthesis here. It doesn't really matter. And so first thing we want to do is U dot V. So U and V, so 3 times a negative 2 is a negative 6, plus 4 times 6, 24. And then we want to multiply that by W, which is, well, we put it in vector form. W is 1, negative 1. So we have a negative 18 times 1, negative 1. It's going to give us negative 18 times 1 is negative 18. And negative 18 times a negative 1 is just 18. Now, last one, u dot 2w. So we'll write u. U is 3, 4. And we want to dot that with 2 times w. So 2, w is 1, negative 1. So this is 3 times 2 times 1, so that's 3 times 2 plus 4 times a negative 2. So that's equal to 6 minus 8, so that's a negative 2. Okay, now we want to find the angle between two vectors, and it has to be, the angle has to be between 0 and pi. And so let's say vector u is 3, 0, and v is 1, 6. We want to find the angle between these two. Let's first plot them. So let's say, here's our origin. V is 3, 0. I'll do it in red. So here's vector, oh, this is u. V is 1, 6. So 1, 2, 3, 4, 5, 6. So here's V. And we want to find the angle between them. And so the formula is cosine of theta is equal to u dot v over the magnitude of u times v. So let's see, u dot v, so it's going to be 3 times 1 plus 0 times 6. So it's 3 plus 0. And then the magnitude of u times the magnitude of v. So the magnitude of u is just 3. And the magnitude of v, well, it's square root of 1 squared plus 6 squared. So it's the square root of 37. So we have 3 over 3 square root of 37, and which is the 3's cancel, 1 over the square root of 37, or square root of 37 over 37. So this is, let me put it here, this is cosine theta is equal to that. So theta is equal to the arc cosine of square root of 37 over 37. Put that into your calculator and you get 80.5 degrees. So that is the angle between two vectors. Okay, now we're going to look at determining orthogonal vectors. Orthogonal vectors are vectors that are perpendicular. So vectors are either, you have one of three choices. They're either orthogonal, or they're parallel, or neither. So orthogonal, if u dot v equals 0. So if the dot product of the vectors is equal to 0, it's orthogonal. Parallel, if u and v have the same slope. And it's neither orthogonal or parallel if it's neither of these cases. So you have a orthogonal, parallel, or neither. So let's do an example. So our vector negative 12, 30 and vector 5/4, 1/2 orthogonal. So we just dot them and see what we get. So negative 12 times 5/4 is a negative 60/4, and 30 times 1/2 is 30 halves. Add those together, they equal 0, so yes is the answer. They are orthogonal. Okay, now we're going to look at a couple of physics problems. So we're going to be using vector components to solve actual physics type problems. And so the first one, I want to solve for the frictional force that keeps the box from sliding down the ramp. So the box has a weight we'll call W. We don't know what it is. But when we draw vectors, force vectors, weight is always straight down, and that's always going to be the hypotenuse of the right angle. And so we'll just draw our vector straight down. We'll call this vector W. Then there's another vector that's called the normal force, which is perpendicular to the ramp. And usually we do that with a dotted line. So draw that in, perpendicular to the ramp. And then there's another force. It's the force in this direction that we'll call the frictional force. And so we just draw that on our triangle to make a right angle here. And so this is the same force right here as this force, W, and then this is the normal force. And forces are vectors, just like velocities and accelerations. And so we know that from similar triangles, this angle theta here is the same as right here. So this is angle theta as well. And so if we look at the sine of theta, it's equal to opposite over hypotenuse. Opposite is the frictional force. The hypotenuse is W. So if we want to solve for the frictional force, little f, F is equal to W sine theta. Frictional forces are dependent upon what the box and the ramp are made out of. It gets pretty complicated, but just for our purposes, we can solve for the frictional force as W sine theta. Okay, the last example we're going to look at is another physics problem, the definition of work. Here's the formula. Work is equal to FD cosine theta, where W stands for work, F is the force, D is displacement, and cosine theta, theta is the angle between the force and the displacement. So let's draw a picture. Say like we have a wagon that's on wheels, and the wagon has a handle. Looks like that. And we want to find, well, let's put some numbers to it. Let's say we want to find the work. Incidentally, W, capital W in physics, can either stand for work or weight or watts. And so what it is depends on what kind of formula it is. So work, we don't know. Let's say it's pulled, let's say 100 feet. So that's D, the displacement. And let's say the force, this force is 30 pounds. And the angle, this is theta here, it's the angle between the force vector and the displacement vector. So let's say it's 30 degrees. And we want to find the work. So work is FD cosine theta, which is 30 pounds. The displacement is 100 feet. And then we have cosine 30 degrees. Put that into your calculator, and we get 2,500 98. Now, the units, pound and feet. Sometimes they use foot pounds. Sometimes they say it's pound feet. Either is okay, and that is pound feet is a unit of work. Okay, that's it for 6.4.